Right. Good afternoon, everyone. Thank you for joining us. It's my pleasure to welcome you to this session on thresholds and triggers for measuring online hate to anticipate real-world harms. So I'm Hayley from Deakin University, and we have three very interesting presentations for you today from my wonderful colleagues at the Tackling Hate Lab. So just as a reminder, please jot down any comments, thoughts, or questions for right at the end so that we can discuss that. So first up, we have Matteo Vagani from Deakin University, who will be speaking to us on where Australian communities draw the line, how targeted communities define online hate. Please welcome Matteo.
Thank you so much, Hayley. Yes, it's a pleasure to present in this panel in which we all belong to the lab, also Hayley. You will see we are a very different bunch because I am a social scientist with some background in psychology. Andrea is an econometrician, Kewan an algorithm researcher. So we really tackle with monitoring, understanding hate and extremism online from a technical perspective a lot. Also, Steph actually is in the lab and presented yesterday her work. So we will talk about some technical stuff, and I will try to, let's say, present some of the implications of the technical ways in which we use artificial intelligence. And Andrea and Kewan will present some data. So the first big issue is about defining what online hate is. Now, this is, I'm going to reflect and show you something from a few projects we have done in which we wanted to monitor hate, and now we talk about what hate is, in the eyes of the targeted communities. Meaning we were interested in knowing how hate looks like in the eyes of the receiving end of the abuse. So to do that, we have to train artificial AI models. And we need to give the AI a lot of examples, labeled, meaning we have to tell the AI, this content is hateful, put it in this box. This is not hateful, put it in the other box. So to do this, and we need thousands of contents, we need a good definition, right, of what hate is. Otherwise, people will disagree and will not know what they are labeling. Well, the QR code is not to steal your credit card number. It's it will take you to the systematic review of definitions and measurement tools of hate we have just published recently. I will cut the story short. So all definitions are very ambiguous. And this is one example. Like this definition is cited a stupid amount of times, like 1,600 citations. And it says, hate speech is language that attacks or diminishes. Now we can all discuss what diminishes mean, but many people will think, well, this is diminishing, this is not, I don't know. And hate speech is language that incites violence or hate. And if you think about it, like hate speech is language that incites hate. I mean, it's just circular. And this is one of the best definitions, meaning definitions are not really helpful. So the thing we do is that we get people from a specific community and we ask them to annotate content, real examples, and then to discuss when they disagree. And we do this for up to 3 months in a very structured way. And we come up with specific guidelines in which community members say, you know, I agree, this type of messages are hateful for this reason. We write down the reasons, we use them as a guide, and we continue until people from a certain community agree on what is hate. And then they start annotating the data. Which takes me to the second huge problem we have, which is how do we get the people to select the people who will train our AI models? Like, I'm Italian, but I don't feel I belong to the Italian community. I don't know. What is it, the Italian community? And if someone speaks for the Italian community saying, oh, Italians feel this or that, do I agree? Maybe, maybe not. So there is a huge problem of representation in communities when you think about who you select, who are the voices you select within a certain community to define the model that will capture hate in the eyes of that community. There is a technical component to this, which is basically explained very well in these two papers, if you want, that the accuracy of labeling tasks does not increase with the number of people you get to do the labeling. So if you get, let's say, 3 to 5 people, maybe up to 10, you get some increase in accuracy of the labeling, and then it plateaus, meaning you don't get more value in getting more people to do the labeling. And also, labeling is the higher cost of doing the stuff that we do. So in the end, the optimal number will be like 3 to 5 people, maybe 4. Now we have to choose 4 people from a community, say First Nations, okay, or immigrants, or whatever it is, to represent hate against the entire community, 4 people. So that, of course, poses conceptual, practical, political problems, which are a lot. So what we do is basically we identify specific organizations within the community. We get these organizations to give us 3, 4, 5 people, and we ask, and then we work with them. We interpret and present the data as representing the views of people from that organization. We don't overgeneralize, and that's it. So be aware when people generalize too much, the let's say, results of a certain research done with AI. Because with AI, you always have to train the model, and you usually need not many people to do that. So it will represent a very specific and biased view of reality. And then the third thing I want to talk about is that when we ask a community to label hate, well, we find out hate is not one thing. You see it here. So these are real examples, okay? And I anonymized them. So it can be, I put group instead of First Nations, Muslim, Jews, you know, women, whatever. So the first one, well, that's incitement to violence. That's really high threshold stuff. The second and the third, well, the third is one that some people in the community, for example, see as hateful, others not. The fourth, there was a lot of disagreement between annotators. Is this hateful? Some had strong views, yes, others not. But you can see, basically, we cannot put everything in the same box. So what we do is to look into what community members classify as hateful, and we distinguish at least between 2 things. High threshold, which is incitement to violence, you know, the serious stuff, and low threshold, which is more the language that diminishes, dehumanizes, etc., where there is no explicit incitement to violence. They are kind of conceptually different. Now, in all the cases, and we have trained the classifiers for like 7 communities across 2 projects, all the annotators agree when they see the example number 1. I mean, everyone agrees this is hate. When they see something not hateful, everyone agree, well, this is not hateful. And then there is a gray area, which we came up with the idea of teaching the machine that it's ambiguous. So we teach the machine to capture hateful stuff, non-hateful, and then ambiguous. And the ambiguous will remain ambiguous. If you have 4 annotators, or 10, or maybe 100. So what I'm going to argue now, and this is what we have seen in the data, and QN and Andrea will show it, is that, and it's a bit counterintuitive, the high threshold stuff is not a signal of potential offline violence, or not necessarily. The low threshold can be. So the high threshold, we said, it's incitement to violence. And of course, it is important to capture, if not just for the reason that, for example, in Victoria, New South Wales, and other jurisdictions, some of this stuff is now illegal. So we need to look for it. But we know that most of the people who write in public forums, stuff like that, are not going to probably do anything. It's performative, right? So it's not at individual level that we can draw a line between, oh, you have written something violent on Facebook or Instagram or whatever, and tomorrow you will go and do something, or maybe never. But we have to review it, of course, because it can be illegal. It's the other type of hate, so the diminishing language, the dehumanizing language, which in some contexts we have found can be a signal, so can increase before episodes of violence. When? In the context of social movement mobilization. So take, for example, Southport, which QN will talk about. So in the UK, we had the stabbing that Rudo Cabana did, I think on the 29th or 28th of July. That was a trigger event. That event triggered a wave of emotions in the anti-immigration movement. And that wave of emotions happened online immediately after the event, before the mobilization offline. And the mobilization was violent. So many of mobilization mechanisms happen following these, let's say, process. There is a trigger event, then online, the social movement start, performing or expressing strong emotions, including hate, targeting certain communities. And then offline mobilization starts happening. And depending on the context, we can see also a lot of that. So in this sense, looking at or monitoring that type of hate, even the low threshold one, can be a signal when you see spikes that go a certain level above the baseline. Well, it tells you something is likely to happen. Look, you don't know for real, 100%, but you have a certain likelihood that this will happen. And then it's a bit complex because real-world violence triggers more real-world violence. Online hate triggers more online hate. And then real-world violence increases visibility of the movement and the outgroup on the media, which gives a platform to people who hate to do it in social media. So this is to say that after the beginning, you have spikes in both online hate and offline hate, and distinguishing between the two becomes really difficult, if not impossible. But at the beginning, after the trigger event, is that we can see spikes and potentially predict the risk of offline violence. And I will let now my colleagues continue to present you some data. Thanks.
Thank you. Thank you, Matteo. And now we have Andrea Giovanetti, who will be speaking to us about network dynamics of online hate and offline harm in post-7 October Australia. I'll bring it up. That's not the one.
That's okay. I can use the laptop. Hello, everybody. My name is Andrea Giovannetti. I'm very grateful to be here. I am an assistant professor in economics at the Australian Catholic University in Sydney. I'm one of the co-directors of the Tackling Hate Laboratory. It's a great pleasure to be here. And today, really, I'm going to present some elements from a project that recently the Department of Home Affairs founded, involving myself, Matteo, Stephanie, Haley, and team. So really a large majority of our team at the lab. We are very grateful for the support that we receive from Home Affairs. As you've seen in the brochure, and as Haley said, there is a component, like the presentation is about a project that tries to understand things happening online, their effect offline, and potentially trying to put things in motion, try to understand how online dynamics may relate to pattern of offline incidents. Now, for the very sake of this presentation, I thought that since time is limited, I will focus on patterns of things happening online, but I'm very happy to discuss also what we see in data related to offline events, that is, accidents that normally are registered at police level. Now, what is the background, the motivation behind our research? It traces back to the events happening on the 7th of October 2023. As we all know, there's been an attack by Hamas and the reaction by Israel. There is an understanding, if you read media or if you work with this data, with communities or with police data, reports, that these events put the entire social cohesion structure of Australia under a gigantic, enormous stress. This has been shown in offline data with spikes of offline accidents surging above 150% against historical normal level. And there's also an understanding that things are happening online. There's a change, a qualitative change in the discourse. Certain topics become heated up. Many more people are entering discussions that we're not usually dealing with. There's new narratives coming through the radar. And what we try to do in this project is trying to assess, to measure, quantify the implications of this event on the online ecostructure of Australia. Now, I said many times the word reports here, because normally reports, if you like me are persons working with police data, you know that reports have merits, advantages. They are normally facts-based. So inside a report, you will find information about an event, individuals involved in the event. If you're lucky, you will also get information on where the event happened, short narrative, and a time span. This is great because it means that you get a fact-oriented information. The problem is that events are not really doing a great job when you're interested in studying the underlying causes, the processes that cause those events, which is what we're trying to do in this research. In other words, our goal here is to look at reports and online narratives, think of these as points, static points, try to put things in motion and essentially connect these dots. How do we do that? We mainly work on data collected from Twitter, X, for a large period, from October 2022, because we wanted to gauge a sense of normality in the discussion before the events of the 7th of October, to March 2025. We perform a very classic exercise of data pooling. We decided around 200 keywords and combination that capture essentially any discourse which is broadly involving or potentially involving anti-Semitic and Islamophobic discourses. And then we try to understand how the quality and the quantity of discourses changing over time and how users change across the time, okay? To give a couple of numbers, it's not really like a gigantic data set, but let me emphasize, this is a filter of discourses that we believe may contain anti-Semitic and Islamophobic content. So it's actually quite a lot of data. It's 2 million actions, where an action on Twitter is posting material, sharing, replying, reacting, okay? Performed by around 100,000 users. Now, it's a lot of stuff. Human society is very dense, and so the discourses that we come along with. So we had to refilter this material, try to produce essentially a priori understanding of what people were discussing. We performed this in many ways, but for this presentation, I want to touch only one of the elements that we look at, toxicity. Now, what is toxicity? From Matteo's discourse, you clearly seen that it's something very ambiguous. It's hard to measure hate in 140 character messages. There's many ways to do that. And in our work, we try to argue that if you're doing a good job, most indicators are going to point toward the same direction. Like the numbers may change, but when you look at the dynamics, they should tell you similar stories. We grounded ourselves on an indicator created by Google. It's called Perspective API Toxicity Indicator. And essentially what engineers at Google did, they collected a really large bunch of data from public discourse, and then they created a system that allows to measure on a scale of 0 to 1, the likelihood that the message is rude, disrespectful, unreasonable, is an attack against identities, and it's likely to make people leave the discussion. So there's like a censorship element in this measurement. I put 2 examples of this classification performed on our data set using the Google indicator. And as you can see, like Matteo said, when the toxicity is high, it's very easy for a predictor to classify the data as toxic. The interesting thing happened at a lower level of toxicity. A toxicity of a level of 1 is generally a straight insult. Very easy for us to catch it as toxic. When you reduce toxicity, it's interesting because the cognitive load, that is the stories that message is telling, are more complicated. You may find argument, or more likely pseudo arguments. You will find elements connected to reality, sometimes paranoia, but those messages are very interesting because they're full of content that we can study to analyze users' behavior. Now, let's go back to all this data. These 2 million actions performed by this large population is almost a city, 100,000 people. And let's look at the aggregate, how the discourse online changed before and after, after the 7th of October. As you can see, before the event, a very small number of people persistently discussed topics that we flagged as anti-Semitic or Islamophobic. The number is quite constant over time. This is reassuring about our selection strategy. It means that we are capturing something that stays kind of constant before the major event. Then yes, you have the event. The event is measured on the Australian ecosphere. You can see there's a gigantic number of people entering the discussion. And these people, interesting enough, were not familiar with those topics. They didn't used to discuss these things before the 7th of October. It peaks at 30,000 unique users after the events. It gets lower and lower. But as you can see, today, this is from June, but recent data shows that there's quite a stable floor, and this floor is around 10 times as high as the pre-7 October period, meaning that we did have a lot of people that entered the discussion and stayed. Now, my background is financial economics, and economists are very familiar with the idea that attention is something very erratic, but once it sticks for a long time. We see it in financial markets all the time. notions, ideas, topics enter in the discussion, companies become popular, we become very interested in their destiny, and we keep engaging with those things emotionally, more than rationally, for a long time. So once something enters in the radar, can be a problem because it's really hard to unfocus, make people disengage from the topic. This is about sheer quantities. Let's look at the quality of the discussion. Let's go back to the toxicity indicator that we use for this data set. As you can see, two things. The total toxicity before the 7th of October is almost zero. It's very low. It's not inexistent. But what I want to say is that after the 7th of October, the quality of the discussion changed dramatically. You had changes in the total toxicity of 3, 4, 5 times as high than the historical average. And at the same time, and this I think is a very good picture that captures the immense stress that the Australian online ecosystem has been put through, you can see the toxicity for action didn't spike on the 7th. There is a very important, I want to bring your attention on this. The number of users spiked around the 7th of October, but the toxicity for action kept growing for about 2 months. So people enter into the discussion, they get passionate in the wrong way, if you like, and then this thing keeps at a very high level for several months, about a year. That means a lot of stress in the Australian ecosystem, okay? That's aggregate figures. You may have seen some similar exercise on other data set. And now I want to bring you the attention at a lower level. This is in aggregate. I want to go at the meso level to understand how atoms, individuals participate to the discussion, how they got influenced, and how they affected the discussion structure in Australia. To do that, I will use a thing that we introduced. It's called influence network. I just give you a very simple intuition of how it works. Suppose we live in a universe made of 2 individuals, and there's one single post. The post is made by individual 2, called Cutthroat. If you work with a far-right extremist, and you know this person. And then you have the other user that reacts to the message of Cutthroat. In our world, in the influence network, you would have 2 nodes, Cutthroat and Elon Musk, the other node, and there would be a link going from Cutthroat to Elon Musk, meaning that Cutthroat is influencing Elon Musk. Elon is reacting to Cutthroat. Let's apply the network to the Australian ecosystem before the 7th of October and after. In this figure, you see 3 main things. There's a lot of people, but most of agents here, most of individuals are not really engaging with other users on the ecosystem, meaning that they may post something, but they're not really influential. Then we have a core of users that influence other users, and they also get influenced by users. And then you can clearly see there's like a difference in the colors. The black links means non-hateful influence. The red links are hateful core. So posts that had been flagged as hateful. It looks big, but it's not gigantic. In fact, these are only around 4,000 users, 8% of the total data set, and it's a very small number of links, about 3%. Let's look at what happened after all those people entering the discussion after the 7th of October. Now you can see there's a much denser structure at the center. There's a high amount of hate. The number of people in the periphery also shrank. Like people start engaging with the hateful core. And an interesting question is, what happened to the people that were there initially? And what we find in our work is that incumbents, that is, people that were discussing these topics before the 7th, are 6.6 times higher, 6 times 6 higher, they have 6.6 higher toxicity than newcomers. So those individuals that were already in the network become more hateful. Not only that, and now I want to make another point that we think is important. Those people that were already in the network become more influential. That is, the newcomers enter in the network by reading messages posted by those users, And keep in mind, those users that were already there, they become more hateful. So they're exposed to a higher amount of hate. This is not, and I want to emphasize that, this is just one of the way a network may evolve. We are saying that in this specific structure, who was important in the network before the 7th of October becomes even more important, and it's more hateful. It holds at individual level, but it also holds at community level, where community for statisticians like me is a cluster. That is, a community is a group of individuals that used to interact with each other, influencing each other. If we look at the communities in the pre-7th of October, and we look at what happened of those communities after the 7th of October, we notice that those communities are still there, but they're attracting much more users engaging with the discussion, okay? One last thing, which is here. 72% of people that were in the discussion before the 7th of October are still connected together after the 7th of October. So those communities were heavily stable. And the second thing, which I want to emphasize, I already said that, but it's important, newcomers, so new individuals entering the discussion got engaged with those communities. Why does it matter? Well, it matters because if our goal is understanding current dynamics and hopefully affect those dynamics for a better future, what we see from this large data set is that the past structures that we've seen emerging before the 7th of October are very important to explain what happened after the 7th of October. So probably monitoring and targeting those groups would have been very helpful to steer the dynamics of the future network. If this thing is still true, having a good grasp on those groups can also help us understanding and probably, controlling future dynamics. I think I'm done. Thank you very much.
Thank you, Andrea. Very fascinating. We have Kuen Liao next, who will speak to us about From Tweets to the Streets, linking online attitudes to offline riots via large language models and statistical analysis. I have this. Yeah, I'll show you. It's automated like that. Oh. There you go. So you don't have it on the.
Okay. Thank you. Thank you, everyone. Thank you for having me to speak in this conference. So I'm another director from the Tackling Hate Lab, directed by Matthew. So I'm from Mala world. I'm from actually I have background in computer science, IT. So I'm a programmer, coder, and then been recently dealing with a lot of AI stuff. I research a lot in AI. And today I changed the title a bit compared to what you have due to I have 15 minutes. So I want to focus on large language models, trying to demystify how we actually use AI or LLMs to detect hate speech, right? So once we get the hateful content, how are we going to do that? I'll give you a little bit background about how we do it as a computer science, how machine can do it, can work on it. So probably this slide has lots of information. So I may ask you, has anyone heard about LLM? If you have heard, you can raise your hand or you understand. Cool, thank you. What about Gen AI as well? Excellent. So yeah, so this is what we draw to let you be more clear about those terminologies, the buzzwords, right, of AI and Gen AI and LLMs. And I believe all of you here, probably most of you here has used ChatGPT, right? So ChatGPT is basically one type of the tool. It's a tool that actually uses LLM, large language models, to do the chat-based kind of question answering type of thing. Okay, so and for ChatGPT, there are lots of complex stuff, like it basically does lots of training, lots of data. You fit into the black box, and then it turns the data into knowledge, into very smarty things. And then also a background in the OpenAI, ChatGPT, they have humans to look at the output to make sure the output aligns with humans' natural understanding, the values, beliefs. So the quote on your right is actually my own definition after maybe 20 years of working in AI. So LLM is basically a very large neural network. So neural networks means some sort of big model with lots of parameters, okay? And what we call transformer actually is one of the names, transformer network. And it pre-trains a lot of data to be able to understand the language, to be able to generate, when you type your prompts, it generates the answers, right? So it can generate tokens or generates words as well. So this is very brief understanding of the LLM. And also to note that for Gen AI, LLM is just one type of Gen AI, okay, generative AI. There are other non-LLM models who can generate things. For instance, diffusion models. For instance, like there are some tools. You type some words, it generate a picture for you, or something. There are other models rather than LLM. So okay, so in the old days, we also have autoencoder, other machine learning models. Well, in the LLM family, there are different types of LLMs. These are a little bit technical. There are what we call decoders and encoders, and encoder-decoder connected, right? Which would the last one, the encoder-decoder together, that's the more traditional, older version invented by Google. So you can see those are the fundamental LLMs, like GPT. ChatGPT is based on GPT model, and Google use Cloud, and also Facebook use Llama, and Alibaba use Qwen. So you can see, I mean, a simple nutshell is to differentiate them is decoders as some sort of generate something, right? Encoders will learn the features of the data and help you to do classification. And this kind of encoder-decoder is like when you're using Google Translate, you type something, translate into another language, it uses this kind of encoder-decoder architecture, okay? So when we use AI model to do hate speech detection or other tasks, then we need to pick the best one. I'll share with you a recipe, step by step, how we can pick it. All right, so this is some definition you probably all know. For me, from my perspective, data science perspective, I look at social media hate speech, which contains, posts, comments, images, even memes, a bunch of multimodal different types of data, all right, which are trying to spread some, harmful things to the targeting a person or group, organization, etc. But as also Matthew mentioned, to judge whether it's hate speech or not is really subjective by nature, and also as we have more, our society is more digitalized, social media are getting more and more having better consequences, right? If we don't control it well, it may lead to cyberbullying or even actual violence. Okay, from my perspective, hate speech detection is basically a classification task. You have lots of tweets, but you want to know, okay, this is hate speech, this is not. So it's kind of we want to have an automatic way, because there are lots of tweets, right? Millions of tweets. We want to have that automatic way using a program to identify, to actually classify whether it's hate speech or not, right? And if it's only in tweets or texts, which you often get in social media, then we call it natural language processing task, okay? But Actually, now our social media is full of, images, videos, lots of things, not only text, right? So so it's getting more complicated. After you detect this is hate speech or not, then we can do a lot of further analysis to see, okay, what kind of hate speech it is and how severe it is, right? And then we can work with government or applying some platform policies, moderate to counter hate speech, or even using other technologies together, like graph, social network technology, to identify who is the main offender, spread those hate speeches. And also we can try to correlate the online hate with the offline events, right? Try to see whether there's some signals that we can use it for predicting the offline events. All right, so this slide may be a little bit technical. So to make machine or program to work with text, the very first step we need to think about is to convert the text data into some sort of numbers, because machines, models, they actually number chunking, they look at numbers, right? You need to convert text into some sort of vectors. There are different ways to do that. And it's what we call is like a text embedding. I embed the text into some sort of vector space, okay? Which is a high dimensional coordinates. You can think about coordinates. And then after you do embedding, it solves the problem of, you have two sentences, completely different words, but they mean the same thing, right? After you embed it to some space, then you look at the examples on the right. The sentence 1, sentence 3, after embed into some numerical space, if they are similar meaning and you compute the distance between these two vectors, okay, then they are closer, okay. Whereas the second one are far away in the space, right? So that's the thing. We need to know. Okay, we need to convert the text to the numbers so that our programs or machine learning models, AI models can use it. Okay, this is the very first step. And then this is one of the, for example, we did for anti-museling kind of study. We have a bunch of anti-museling types of tweets. We want to detect whether it's anti-museling or not. And then what we did is we embed those texts into the high dimensional space, and then we use a tool called TSNE to project it down to 2-dimensional space so human eyes can take a look. And then we can see that for different types of these kind of tweets, actually it's very hard to classify. They don't have a clear boundary to classify them, right? This shows the difficulty of hate speech detection. It's actually quite difficult in semantic space. They are quite cluttered, okay? So that's if we don't use LLM, we don't use AI, then it's difficult for any ways to do it, okay? So this is some motivation. And next is how can we apply what I mentioned, decoder, encoder would have a different range of LLMs. So our goal to use this AI model LLMs is to convert this kind of harder representation to an easier one, what we call contextual embedding. I will show you how it looks like in the next slide. So basically, I need to use a neural network to convert it to a better representational embedding space. Not like that. It will be like that. Okay. After you use the LM, going through the AI model, those texts, they will find a space such that they embed into that space. These texts will naturally separated. So hate speech detection becomes easier. Okay. So the steps I will follow is basically first I need to pick a model, right? You need to think about whether you need to use encoder based or decoder based, and then whether you want to use the paid version like a GPT, if you want to use the API, this paid version, and there's also the open source free version. You can download into your local computer and play it by yourself. So you can see all the model, different layers, the parameters of the model. Whereas for the proprietary version, you need to buy the OpenAI tokens and call and use it via the API, right? And your data will be leaked as well. But if you use the open source one, you can download it, build your own environment. So once you select the model, then you need to do the task adaptation. What I mean is you need to because those models are pre-trained on general data, but you have a particular task, a particular problem, right? You need to adapt this model into your problem domain. Okay, so there are a bunch of different ways. Easy. The ways we use every day is called prompting, right? We're just typing in the chat. This is a prompting way, and for data scientists, we normally will just using a program to actually invoke the model and to fine tune the model. Just issue some commands to fine tune the model. The actually internal mechanism of the model. Okay. For both this prompting and fine-tuning way, you can do zero shot, a few shot. I'll explain what it means. So basically, you can provide some examples to them, or you can just let it just inference, like what we do in daily basis. Okay, yeah. So this is the example of a zero shot and the few shot. Zero shot basically just type what you want. Few shot is you give some examples. Your expected output, right? So basically, the few shot will change the output mechanism of the LLM, so it will he will be guided by your domain knowledge. Okay, and then after I use LLM, so I will have those embedding space, and hate speech detection become a lot easier. Okay, so that's the magic behind. Well, lastly, I want to just quickly share with you one of the SourcePort dataset, or UK rights dataset Matthew mentioned. So it's a large dataset, but we have a very limited training examples, and this very imbalanced dataset. We also doing a multi-label classification. So it's harder, which means each tweet may belong to any of the top 4 categories. Doesn't mean one tweet only belong to one category. It can belong to multiple categories, okay? Unless you are no category. And primarily, we want to detect to see whether there's any anti-foreign hate or anti-politics hate. That's our main thing, okay? These are the examples here, which I just you should be familiar with. So we run a lot of large language models, range from Robota, human open source one, Robota's encoder-based one, GPT generative one, and we have also for each model, we have different adaptation way. We have reasoning, we have prompting. I don't want to go into too much details. So we got lots of models, and those numbers, you can just simply treat it as accuracy, how accurate you detect, okay? So that's basically the result. And then we found GPT 4.1 gives a better result overall, but Qwen is also good because GPT 4.1 has a much bigger model, like has billions of parameters, hundreds of billions. And so this is a consolidated result. Interestingly, we found using large language model can achieve human level reliability. Basically, out of our annotators, we randomly sampled one annotator and look at how that person can classify in those the hate speech into those categories, and then we found the best ones actually achieving the human level. So it's really amazing. And also, we found that if the model is really big, we don't actually need to do few shot. We don't need to provide example. We can just do zero shot. It does pretty well. Okay. Finally, once we get the data, we will collect the counts or the positive ones we detected, we will collect the counts. And we also have another offline instant data. We're trying to correlate them. Okay, we're trying to correlate them. So this is one of the measure. We try to compare the total tweets volume against the event volume, right? So these are the days, and then the count is actually the total number of tweets. So we found that anti-politics messages appears to be more sensitive, whereas unfortunately, we can't find some strong indicator because those surge in the tweets volume actually co-occur with the events volume, right? So we want it to happen before, so we can predict, the actual event volume. So next, we try another interesting way is looking at the reposting rates. So instead of looking at the total amount of volume, we look at even before the event happening, we look at we keep monitoring the ratio of the retweets. For you have some original message, right? And then you have lots of people retweets. So if those messages, we call it amplification. So if these messages got retweets a lot, during that time, and then it means something, right? If you look at the top one, here, even before the event happens, this measure, reposting rates, actually kind of showing some sort of early signals. Yeah. So that's something I want to talk about. Yeah. So I think we think this is a more reliable measure and indicator. Okay, that's all for my presentation. Thank you. Sorry for overtime. Yes.
Thank you, Kieran, and everyone on the panel. We have about 10 minutes or so for thoughts, comments, questions that anybody might have. Yes, we've got some mics just to this. Thank you.
Thank you very much, everyone. It was a different project. That's why it is informing as well. I'm very much interested in exclusion criteria because in such a controversial time and politically heightened as well, so definitions are very blurry. It may change from one community to the other. Starting with Andrea, maybe my question to him, when he is talking about toxicity, is it are you using it for inclusion criteria or as a scaling criteria? This is one thing. And you talked about toxicity content. So does that mean, because we are going to pretty messy and toxic environment, yes, but incidents are as well. So you're calling it war, but another person can call it, let's say, extermination of a nation in its homeland, which can be defined as XYZ. And another community can call it, okay, I'm feeling threatened because this is targeting that country. So that becomes pretty messy. That's why I'm very much interested in what are your exclusion criteria. And this is another question for Meta. Because you're talking about these definitions, it can be, yes, how communities are feeling about the definition is important. But if you're doing cross-community work, where do you find the, I think, consensus? Because, and also persons from community, yes, matter. But in the meantime, what is the academic established tangible criteria as well? Sometimes it's really about lobbying, or it can feel like one community can feel this way, another can feel that way. To me, what is your clear definition which can work across communities without losing the authenticity of how they feel about? Again, we are talking about very sensitive time. That's why that is bringing me to the fourth findings of Andrea, which was about, I think, guessing what can happen in the future. I don't agree with this comment because we need to really see after everything is resolved. If we see the same patterns, then we can guess what will happen in the future, because as we said, we are going through very extraordinary times. So just looking at these, we can't really estimate what can happen in the future. It can be, to me, a speculation. Sorry about that. That is just my personal opinion, but that's my logic telling me to, I think that way as well. Thank you very much.
Thank you so much, Daria. I will just start, and then I will let Andrea respond on his part. So I guess, I mean, with most of the concepts we are working with, there is a somehow factual component and a somehow subjective component. And you cannot remove the subjective one and pretend it doesn't exist, because it exists. So the only way to make more objective the measurement is to focus, for example, on more higher threshold types of hate. Like if you incite violence, if you say we have to kill these people, right? Or we have to get rid of these people, that's the best objective threshold. And this is why we try to distinguish. So we have a ad hoc classifier that looks at only incitement to violence, that cuts across communities. If you incite violence, you incite violence. Now, then there is the other subjective element. And that element, look, we are in the realm of opinions, I think. My opinion is that you have to be able to explain which type of subjective view you are representing. So this is why, as I said, our approach is to select, I don't know, for depending on the classifier, we work with specific organizations. We try to get annotators from these organizations, and we don't claim that the view that the AI is trained with represents the whole community. It represents that organization. So if you want to understand how people in that group feel and what they see as being hostile, diminishing them, attacking them, making them feel bad, well, this classifier works. It shows you how people in that community feel, and the amount of stuff that people in that specific community, which can be even transgender, First Nations, whatever it is, how they feel when they see the volume of stuff that make them feel excluded from society. And then you can think about the implications that that has. But this is where it stops. It's not a normative project in which we say, hey, people, this is what hate is. No. I mean, we can say, hey, people, this is how much incitement to violence there is. But then we say, this is what people perceive in some parts of the community. That's the approach.
Relative to my question, so it's a very interesting point. It's very important as well for us as econometrician, the points you mentioned. And I didn't have the time to talk about it, but you may have noticed, you surely did, that when I discussed very briefly the data collection part, I mentioned that we use these 200 keywords and combinations. So it goes well beyond like 1,000 possible combinations to make sure that literally all possible related topics to what we believe trigger a change in the discussion online before and after the 7th of October is in the data. Now, why did we do that? Why did we do that? The main reason to reframe, and I apologize if I look simplistic, please correct me. But the problems you mentioned for us enter into a discussion on the sensitivity of your analysis. I try to explain what I mean. If we change a bit the number of the keywords, their combinations, there is a risk that this graph would look very different. That's why we consider many possible combinations to make sure to have this broader setting. Now, the setting is large, it collects lots of information, what is hate and what is not hate within that set of data. If your indicator is sensitive, it means that small changes to the parameterization can tell very different stories. And one big challenge for us is avoiding that. Now, how do we do that? I didn't have the time to explain, but first we look at the subset of comments that show a toxicity, say, about above 9, 0.9, so very high level. And then we look at lower level. And the question we ask is, how do these things change in time? Because we don't have like an absolute measure of the phenomenon, but given a definition, given a measurement, given a subset, we can see how this thing changes in time. And seeing like that the indicators spikes, regardless to regardless to the amount of hate that you are looking, and you see this constant spike, then it's telling us that probably something substantial is happening. It's a very agnostic approach, precisely because we want to avoid a situation where you make a small change in the angle of observation, and then you end up actually discussing an entirely different sort of dynamics. Coming to your second point, what is too close to the fact to make an objective assessment about this very complicated long-term dynamics? I agree, it's very complicated to say. I mean, time is limited in the future, in the sense that we could collect data up to essentially today. We don't know what's going to happen in the future, and we had also some constraint relative to the past. But maybe I will like reduce a bit the intensity of my previous statement. Let me rephrase it. What we see today, November 2025, is that we do have around 100,000 individuals that enter discussing certain topics with a certain amount of animosity, and most of them are still there on the platform discussing those topics with those, behavioral traits. I'm not saying, this is concerning. I'm saying this is very different from what we observed before the 7th of October. That's the only point I wanted to make. In terms of making qualitative statements, sure, like we would need to study the data using different different classifiers. Again, this is just an indicator of toxicity that shows things changing in time, but the same thing you can analyze from different perspectives. And probably delving into the narratives, you would see many other things. So I didn't want to oversell like a perspective. It's a very limited angle, what we've shown here. I hope it makes sense, but I'm happy to discuss it further.
Thank you. We are running out of time, but there was another person. If we could just have a quick. Yes, please. Yes.
I'll try and make this quick. My question's for Kieran. When you've talked about how LLMs can achieve human level reliability, I just want to ask to like unpack that a bit further. So do you mean from like an individual level, or more so like a inter-rater reliability? So like, let's say two humans with two independent perspectives getting together consensus. Like what's the reliability we're looking at here?
Hi, great question. So basically individual, and we have 5 annotators. We randomly pick one, look at how does that person perform against how our AI model is doing. So not like, because if we interrelated all 5, then we get the ground truth. We use that as a golden ground truth, but we just randomly pick one. And this is just for this data set. It might be different for the other. Yeah, but it's a great question. Thank you.
Thank you. I'm just going to squeeze in one more question. Andrea, you showed us a slide where after the incident, there was an increase in all of this hate speech online. Because we are running out of time, are you able to answer in one word? I doubt you can, but I don't want you to go back to your computer and do all these numbers. Which would be more useful, to decrease toxicity or quantity in your view?
It's an amazing question. Look, the target normally would be toxicity. The problem is, how do you reach reduction in toxicity? It's easy if you can make a connection between toxicity and the user population. So if you see that there's some users that express consistently in time a high amount of toxicity, then those are like, we call them the gatekeepers. Those are like discussing those topics before the 7th. They're also there in the post-7. High volumes, high toxicity, and many newcomers enter in the network through the influence of these people. Then, of course, targeting those individuals reduce both volumes and toxicity. Other than that, it's very complex. We can have a discussion and we'll be very happy to discuss it, but you need to handle with a lot of care, of course.
Thank you so much. So
You're
for
welcome.
researchers, let's go target them. That was the answer. Thank you. Thank you all.